Hi friends, today we are going to see an interesting subject which is related to database. In our white paper series, today I have taken this paper because most of on-premises are migrating to cloud. So when it comes to database, what kind of best practices AWS is offering us? So that is where we're going to check today. And if you see this paper has been published already in 4 years, but recently it got updated in March. So that is where no, it's been a year, but again, it's good to go ahead and see how to migrate your existing on-premises database to cloud, which means to AWS. So let's quickly go and check the content. Overview of migrating data-centric application to AWS, migration steps and tools, what AWS offering us to do it freely. Then migration assessment, schema conversion, conversion of embedded SQL and application code, data migration, testing converted code, data replication, deployment to AWS go live. So this is pretty much clear. Like when you have on-premises application, the database, you need to first do an assessment. So once you do the assessment, then you need to do some conversion. Uh, there are tools, but let's see. When we do the conversion, it's go to the embedded the SQL and no like application also need to be changed because you are pointing now to the cloud database instead of the on-premises database. Then once we have a new database, then data should be migrated to it. Then we test it whether the newly migrated data in the database everything is good. Then data replication is a DR, like we can have multiple instance for replication. Then actually you are live in AWS for your database. So the best practices is schema conversion. How we going to do application code conversion, data migration, data replication, testing, how we can test it, and deployment to go live, and post deployment monitoring best practices. So it clearly gives us best practices in all the steps. So AWS has a tool called schema conversion tool, SCT, and data migration service, DMS. So these tools are essential to migrate an on-premises database to AWS Amazon RDS, Relational Database Service. So this guide will be beneficial for us to understand how to migrate the database to RDS, schema, data, application code, migration process, all this will be discussed. And the target database can be Postgres, MySQL, Amazon own SQL database called Aurora, MariaDB, Oracle, SQL servers. These can be your targets. So you can choose any cloud, any database uh, you like to have as a target database, and what you have is in the on-premises your source. So source can be you should this source, like if your source is MySQL and you want to move to the target as MySQL, it is available. So yeah, let's see a detail. So if you see customers increase the cloud, yes, that's the reason, and we need store, process, analyze large amount of data. AWS is modern, scalable, secure, and performance platform to address the customer requirements. Of course, is cloud. AWS develop application deploys to cloud using combination of database, application, network, security, component, storage. So basically, AWS has all the different service like compute, storage, network. So it gives you the complete infrastructure as a service. On the most time-consuming task involved in application to AWS is migrating the database schema and the data to the cloud, because data, when we talk about data, it can be huge, like it can be TB, or it can be more GB, or all right. So that time of migrating the data uh, takes more time. So AWS schema conversion tool and then AWS database migration are invaluable tools to make this migration easier, faster, and less error prone. Amazon Relational Database Service is a managed service that makes it easier to set up, operate, and scale relational database in cloud. So basically, we are not going to install in Windows or Linux. So Amazon ODS is already available. We just going to click and create it, kind of software, platform as a service. It provides cost-effective, resizable capacity for an industry-standard relational database and manages common database administrative tasks. All the administration tasks mostly Amazon take care because we don't have the um, underlying infrastructure maintained. So yeah, the simplicity and ease of management of RDS appeals to many customers who want to take advantage of disaster recovery, high availability, resiliency, scalability, and time saving benefits to the cloud offer. The, the main reason we go to cloud is scalability and availability, security. Basically, you want to have two regions, disaster recovery, RDS as a solution for it, high availability, resiliency. Okay, so Amazon RDS currently supports MySQL, Aurora, the MariaDB, PostgreSQL, Oracle, and MySQL. So mostly it supports major database softwares. In this guide, we discuss how to migrate the application using Relational Database Management System (RDBMS), such as Oracle or MySQL, onto a RDS instance in the AWS cloud using SCT, which is Schema Conversion Tool, and AWS DBMS, Database Migration Service. This guide covers all major steps of application migration, database schema and data migration, SQL code conversion, and application code replatforming. So application code replatforming, re-engineering also another word, but that's fine. Overview of migrating the data-centric application to AWS. Migration is the process of moving applications that were originally developed to run on premises. Now it need to be remediated for Amazon ODS. During the migration process, a database application may migrate between two databases of same engine, like either Oracle to Oracle or SQL to SQL. That could be one case. Or between two databases that has two different engines, like Oracle to PostgreSQL or SQL to MySQL to MS SQL to MySQL. Can be heterogeneous migration or homogeneous migration. In this guide, we look common migration scenarios regardless of data engine and touch on specific issue related to certain examples in heterogeneous conversion. Basically, homogeneous conversion might be very easy because data transfer from same platform. But when you talk about heterogeneous, it's two different database, right? Application migration to AWS involves the following steps regardless of database engine. So these are common steps. Don't worry about you use MySQL or Oracle. So these are common steps. First step is to migration assessment, then schema conversion, application code conversion, migrate data, testing, data replication, go live. Let's go in detail. So migration assessment overall effort is 2%. Schema conversion takes 30%. Embedded SQL and application code conversion takes 15%. Data migration takes 5%. Testing takes 45% of the effort. Data replication takes 3%. Go live takes 5%. So this is to identify where you're going to spend your more time in the migration phase. And more time is spent in schema conversion and testing the data. So to make the migration faster, more predictable and cost effective, AWS provides the tools. So we already discussed about the tool, but so it's a desktop tool Schema desktop tool that automates to convert the database objects from different database migration system to different RDS targets. So you can choose Oracle to Postgres in this case. This tool invaluable during the migration assessment, schema conversion, and application code conversion steps. DBS service, a data migration to AWS database targets. AWS DBS can be used for a variety of replication tasks, including continuous replications of offloading reads from primary production server for reporting or extract, load, continuous replication for high availability, database consolidation, and primary replication of data migration. In this guide, we focus on replication needed for data migration. This service reduces the time and effort during the data migration and data replication steps. So data replication, actually you will have a data in on premises as well as cloud. So you're going to replicate the data, not going to actually move it. So let's see. So development environment setup prerequisites. What is the prerequisites we need to have? So the prerequisites is we need to have an EC2 machine or a VM, and we need to download and install this tool. It's just pretty forward installation. Like we need to, if you click on here, it shows the download component, and if I click Microsoft Windows, then it downloads the zip file here. So this installation steps is like how we are installing based on the we your operating system you wish. Like if you are Linux, then you can choose Linux and then install it. So it's very easy. So once you installed it, now during the assessment stage, basically a team of system architects or a team of people who need to have a meetings, talk together, and then make a network diagram of how the application is connected and how we can migrate. So this is involves more of discussion to analyze, but so this tool helps to create a assessment report with AWS. So this tool gives you a assessment report. So basically, once you put the data, it gives the assessment report in the PDF or CSV format. So it is saving the time of the discussion and stuff. So so that is one step they are telling. So but how it is actually doing the assessment? Identifying the schema objects, tables, views, store procedures, triggers in the source database, and action that to convert them. So what is the actions items to convert them to target, including full automated conversion, small changes like selection of data types, attributes to table, rewrite of. So even so it is considering from the source, it is taking everything and it is trying to run a scan and see what are the action item required for your database, and it recommends the best target engine based on the source database and features you have, and it recommends the AWS service that can substitute for missing feature, recommends unique features available in RDS that can save customer license costs. So these all recommendations based on the report, it gives a lot of recommendations, and also it recommends the re-architecting of to the cloud. For example, sharding a large database into multiple RDS instances, such as sharing by the customer or tenant, sharding by geography, sharding by partition key. So separating the data into different instances. So even though you have it in one instance or three instances, that doesn't matter, right? How much data you are going to load. So that gives some recommendation, kind of architect decisions where your architects can take or the developers can decide. So the report selection. The database migration assessment report involves three main sessions: executive summary, conversion statistics graph, conversion action items. Okay. So if you see the executive summary provides the key migration metrics and helps you to choose the best target engine for your particular application. Conversion statistics graph. This conversion statistics graph visualize the schema objects and number of conversion issues required in the migration project. So it gives triggers, views, store procedure data. So it is giving a graph kind of And conversion action item are presented in detailed list with recommendations under. So it gives a recommendation like simple task, medium task, significant task. So significant task will take more than, like, requires 4 or more hours to complete. So using this report, we can decide upon what kind of decision we need to take. Now we we are seeing the second feature in the tool called schema conversion. So schema conversion has two steps. One is converting a schema and applying the schema to the target database. So this tool converts the store application code in trigger, store, and simple. It's kind of, if you remember, like if you want to convert your PDF to Word, you use some online converter to convert the format of PDF to Word or Word to PDF. Because think about Microsoft Office needs to cannot open the PDF, that you need a Adobe reader or some PDF reader. It's the same like that. Make it very simple. So this STS going to your source might be MySQL, and you can use Postgres or it's SQL to SQL. So anything is fine. So this is going to convert or take the schema ready for applying or no install it in your target database. So basically, it automatically creates a DLL scripts, which is a database scripts for database objects on the target platform as soon. For remaining data object, the conversion action will describe why the object cannot be converted automatically and the manual steps required to convert. So sometimes it also tells that I cannot convert automatically with the reason, and we need to do some manual stuff. Reference to the architect recommended solution on the target while in our, so they also have some recommendation. So to handle manual conversion items, lastly apply all DLL to create all objects to once. In this case, sometimes your MySQL team or MS SQL experts will also help you. Like if you ask, I'm going to migrate from MySQL to like MS SQL to another MS SQL database, you can check with Microsoft how we can do that. And if that recommendation also will help you to convert or to take a decision on steps. And they finally the data replication. So you have a database schema, but you need to have the data to speed up that. The database replication will load the initial data with the DLL script already created. After the database migration assessment report is created, this offers two projects: main view and assessment report. So it offers two things like a main view and assessment. If you see, this is the assessment report. So they show 4 parts: one, two, three, four. And the first part is of the code where the database is has been highlighted. The second part is on expanding the object, like in the code where we need to give. So basically, it gives some recommendations here. I'm not going in detail. Here, at least if you guys understand, there is a tool called a schema conversion in AWS to help you to migrate from your on-premises. That's well and good. So, so you can go through this white paper fully, and then let's go to. I'm not going in detail, so it will take more time for us to go through. I will give this link in the description. If you guys want to read completely, you can read. But I have briefed you high level on the schema. Now, if you see here, when you choose the data replication, right? Here in the tool, it shows you like this. So target table preparation mode include CLO columns in replication. So basically, by default, it is selected like how much you want to have limited mode or a full mode. So it is UI based thing, and they have given the settings also. What it actually means when you say full LBO mode, what does it means? Limited LBO mode, what it means? Then deployment to live. So basically, your database will be ready and it will be fully running. So you can connect to the endpoint. The best practices here are So you need to save the database migration assessment report for future purpose as CV or PDF and have it for your reference anytime someone want to evaluate why you are using this database. It will help you. For conversion, applying DLL targets in order, we need to avoid the sequences, tables, views, and procedures. So, what they are trying to say, apply to target in order to avoid dependency errors. So, function should be applied to the target database in order, for example, a function might be referred to the table column. Therefore, the function must be applied before the table to avoid the dependency error. Okay. So, if data is going to be there, data needs to know which table I need to write. So, first table should exist there. So we should see the sequentially the migration is happening, not just going into the last stage of order. So that is makes sense, right? And configure the tool, this SCT tool with the memory performance settings you need. So memory performance, because during the migration it may take a lot of memory from your desktop. So on the desktop, if it is a limited memory, then the time of your migration takes high. So they're saying settings, global settings, and then performance and memory. So increase the memory to your. It's better to use a higher end laptop or like higher end machine, higher end EC2 machine to have this migration. Apply the additional schema that AWS tool creates to the target group. So there are some additional schemas like see it gives like source platform, right? Like additional platform, additional schema is created. AWS, for example, MySQL, ext, which is external, or this functionality. For example, when you're converting from MySQL to PostgreSQL, it contains the sequence to replace the SQL identity columns. Don't forget to apply the additional schema to the target. It will also have a direct mapping to the source object. So in case if it doesn't work, so still you have that schema to go into SQL, kind of a backup. Use source code version control to track the changes to target updates both database and if you find bugs for data during the testing and the changes. So this is CI/CD. So they say they refer you should have a source code repository and then deploy with the versions. That's a good best practice as well. And the application code conversion after running the initial application assessment report through the CVC. So same like that. Migration best practices, especially database data mining, we usually use this DMS tool to actually replicate the data. So choose the replication instance class large enough to support your data size and transaction load. So choose the instance while you use the DBMS to run the choose dbms.c4x large kind of instance. It is high, but we are not going to use this instance after the migration. Like if your migration takes 1 day, then you can delete that instance. So have a higher end instance and because people choose free instance or T2 instance and then it shows like 18 hours to migrate. But of course if you choose the higher instance, it can migrate very fast and even in 18 hours can become 2 hours as well. On the target database, disable what is not needed. So disable unnecessary triggers, validation, foreign keys, secondary index on the target if possible. Disable unless unnecessary jobs, backups, logging on the target database. So in target database, make sure all the settings are right. Tables in the source database that do not participate in common transaction can be allocated to different tasks. Yeah, tables in source database, right? So source database you are already migrated and still you have some transaction which is there. So you can allocate a different task for it. Monitor the performance of source system to ensure it is able to handle the load. So you should always keep on monitoring it and you should enable the logging using the CloudWatch log so that if we have any errors in the database, we can eventually find it out. During the database replication, archive best performance by not applying indexes of foreign keys to the target database during the initial load. During initial load, don't apply the indexes or foreign keys. The initial load existing data, therefore you can best performance during the initial load of target database does not have indexes. However, after the initial load, when cache data changes are applied, indexes can useful for locating rows to update or delete. Apply indexes and foreign keys to the target database before the application is ready to go to live. See, during migration, like it is not needed, but but when you go for application, then you need to apply the indexes. For ongoing replication, enable multi availability zone. So just ensure your high availability is taken care when your application is ready. Use API or a command line interface for advanced database migration task. So you no need to every time go into UI. You can actually try to use CLI so that you can also have it a Jenkins job or something. Disable backups on the target database during the full load or perform. So if you disable the backups so that at the same time backup is not running and take time, all right, wait until cutover to make your target database multi-SG. So wait till the cutover time, like the data in your source should not be still using, because when you move you will still have data coming in. So make a cutover time and come to your target, and let application speaks to target, and then from there all the data goes to your target database. So testing best practices: have a test environment with full regression test for the original application to be conducted. You should have a separate infrastructure like a UAT, for example, where you can test everything like pre-prod. In absence of automated testing, run the smoke test on the old and new application. So if you don't have something automated testing, at least run the smoke test. Smoke test is kind of testing the UI functionality by someone can click and check and how it is responding. If in your old application it is coming fast and new application it delays, then there is something wrong. So the new application should be faster. Applying standard practice for database driven software testing regardless of migration process. So the converted application must be fully retested. So just test your database to ensure that migration really helped, has no issues. Have sample test data is used for testing. So like some applications like payments or cars, they need transactions, they need users to log in. Have a sample data, like created a synthetic data, take the data from production and mask the sensitive things and make synthetic data. Have a test data to test it. Don't just test the service or something. You try to load the data and then try to test it. Know your data logic and apply it for your test plans. So like if you don't have a correct testing, then that's a problem, right? So you think it's tested, but when you go to production it may fail because you need to do the correct test plans. Test using the data set similar in size to the production data sets to expose the performance bottleneck. Yeah, that's what. If you have to 10 TB in production, just ensure you are running with 10 TB in testing also. Deployments and go live best practices. So here, when you do deployment, ensure you have a rollback plan in case your application is getting failed. Or you going to use your older database, the source database is still running, and you can go back there and then try to see what is failed, or you need to see how kind of rollback you have. Test the deployment on staging and pre-production environment. So as you the previous step you would have tested more onto the database, but here they also say you also test the application more. Verify the DMS has reached to the steady state, which means DMS is migrating your data. Make sure it migrated all the data, and there is a cutoff to the old application, and no more new data is coming to the old application. Verify the database maintenance job in place. So such as if you have backup is running or something is running, when you go live, ensure that is not happening. That maintenance should happen after the business hours. Turn on multi-AG if required, like for application. So previously we discussed for database, but if you want verify the monitoring in place, it's more or less same. And post deployment monitoring using CloudWatch logs, monitoring logs. So monitoring is people understand what is monitoring, what is logging. But if you need some clarification, you can actually also comment so that I can. The logging and monitoring itself is a separate topic. Monitoring the instance health, so you have to do all the monitoring things. So the conclusion here is, in the white paper what we learned is, we learned two tools is available in AWS, which is a schema conversion tool and then database migration service. Make the process of moving your application to the cloud much faster and easier, and then uh, faster than manual, of course, together by saving hours of deployment migration effort. So previously we saw how much hours it will take, in the percentage at least, right? Enabling to recap the benefits of AWS quickly. So, so we come to the end and hope you guys got some insights on how we can migrate your on-premises to AWS. So thank you guys. Bye.